One of the most concerning developments in medicine is the emergence of bacterial super-resistence. Resistance to not just one class of drugs like penicillin, but resistance to multiple classes of drugs, so-called multi-drug resistant bacteria. In the 2013 FDA Retail Meat Report, more than a quarter of the salmonella found contaminating retail chicken breast were resistant to not one, but 5 or more different classes of antibiotic treatment drugs. Throughout history, there's been a continual battle between humans and pathogens. For the last half-century, that battle has taken the form of bugs versus drugs. First, we developed penicillin, and the U.S. Surgeon General declared the war against infectious diseases has been won. However, the euphoria over the potential conquest of infectious diseases was short-lived. In response, bacteria developed an enzyme that ate penicillin for breakfast, literally an enzyme that breaks down penicillin, called penicillinase. In fact, they can excrete large quantities of the enzyme, so it can destroy the drug before it even comes into contact. OK, so we developed a drug that blocks the penicillin-eating enzyme. That's why sometimes you see 2 drug names. One is the antibiotic, and the other is a drug that blocks the enzyme the bacteria uses to block the antibiotic. But the bacteria outsmarted us again, and so it goes back and forth. However hard we try, and however clever we are, there's no question that organisms that have been around for 3 billion years and have adapted to survive under the most extreme conditions will always overcome whatever we decide to throw at them. So we went from first-generation antibiotics to second-generation antibiotics to third-generation antibiotics. But now we have bacteria that evolved the capacity to survive our big-gun third-generation cephalosporins like ceftriaxone, which is what we rely on to treat life-threatening salmonella infections in children. Where are these super-duper superbugs found? Almost 90% were isolated from chicken carcasses or retail chicken meat. But what if we only eat no antibiotic-added, organic chicken? A comparison of these multi-drug-resistant bacteria in organic and conventional retail chicken meat, the first such study ever published. All of the conventional chicken samples were contaminated. However, the majority, 84% of organic chicken meat samples, were also contaminated. So 100% versus 84%. Organic is definitely better, but odds are we'd still be buying something that could make our family sick. But where do these antibiotic-resistant bacteria come from if they're not using antibiotics on organic farms? A possible explanation is that the day-old chicks coming from the hatcheries are already infected before they arrive, or they can become contaminated after they leave in the slaughter plant. Organic chickens and conventionally raised chickens are typically all slaughtered in the same slaughterhouses, so there may be cross-contamination between carcasses. And finally, factory farms are dumping antibiotics and antibiotic-resistant bacteria-laden chicken manure out into the environment. You can pick up antibiotic-resistant genes right out of the soil around factory farms. So even meat raised without antibiotics may be contaminated with multi-drug-resistant bacteria. In a cover story in which Consumer Reports urged retailers to stop selling meat produced with antibiotics, they noted some store employee confusion, though maybe they were not so confused after all. An assistant store manager at one grocery store, when asked by a shopper for meats raised without antibiotics, responded, "Wait, you mean like veggie burgers?"